Welcome back to another video. Here I'll be solving this 1969 AP Calc AB multiple choice. This is in the old format of the exam, but there's still some good problems, so I'm going to solve them. Okay. For those of you that have been seen the videos on my channel, you might have noticed that I've solved this before. However, in that video, I catered it more toward UCI Math 2A and 2B, solving the problems for students who are in 2A, and another video solving the problem for students in 2B. Now that my channel has become more generalized, not to just UCI Math 2A and 2B, I'm going to be resolving this as a test. Resolving this test as a whole, no differentiating between those two classes. Okay, so let's begin right away. Okay, you are allowed 90 minutes for this. I probably will split this up into a few portions. Okay, because I'm gonna go slow for some of them. Okay, and of course, because it's an old exam, some of the problems might not be relevant anymore, but like they don't explicitly teach it maybe in AP Calc AB anymore. So I'll leave it up to you as to whether some of the content is relevant or not. Okay, but you should know most of it. Okay, it hasn't changed too much. Okay, so let's begin. Number one, which of the following defines a function f for which f of negative x is negative f of x? You should recognize this is an odd function. This is literally the definition of odd function. When you have f of negative x, it's negative f of x. Which one is it? Okay, if you don't remember this is an odd function, you can just simply plug in negative x as x and see which one gives you negative f of x. Okay, since we know it's an odd function, let's just go by the choices. We know this is even. This is neither odd nor even. This is odd. This is neither odd nor even. This is even. So the only answer is B. Okay. ln of x minus 2 is less than 0 if and only if what? So this is asking kind of the domain. Okay. When is the log negative? We know ln of 1 is 0. So anything... So when we're just talking about ln x, when x is less than 1, but greater than 0, because the inside of the log cannot be 0, right? That's part of the domain of log. So when x is between 0 and 1, then it's negative, okay? So that's for ln x. We have ln of x minus 2. So x minus 2, this guy has to be between 0 and 1, okay? Whoops. So we just add 2 everywhere. So 2 less than x less than 3. Okay? And that is choice C. Hopefully that makes sense. One more time. We know ln x, let's go by this one. When x is 1, we have ln 1, which is 0. And then anything less than 1 but greater than 0 is that log is negative. Okay? So instead of x, we have x minus 2 here. So we put x minus 2 is between 0 and 1, and then we solve for x. Okay. Next, we have this piecewise function. I'm not going to read it out. If f is continuous at x is equal to 2, then k is equal to what? Okay. If f is continuous at 2, remember what that means? That means limit as x goes to 2, f of x would be f of 2. Okay. That's definition of continuity. So we got to find the limit as x goes to 2, x approaches 2 of this guy. Okay, so we might need a piece of scratch paper for this actually. Give me 1 second, sorry. Okay, so I don't know where my small sketch pad went, but here I'll use my big one. Okay, we want to find, as we said, limit x approaches to 2 of f of x. So we want to use this top one. We have 2x plus 5 minus square x plus 7 over x minus 2. Of course, we try to plug in x as 2. What would we get? We get square root of what is that? That would be square root of 9 minus square root of 9, which is 0 on top, and then 2 minus 2, which is 0 on the bottom. 0 over 0, indeterminate, so we gotta do something else. Here, the technique is we use the conjugate, so we would multiply by square root 2x plus 5 plus square root x plus 7 on the top and the bottom. Why do we do that? Well, we get limit as x approaches to 2 of, here we FOIL it out, we would get 2x plus 5 minus x plus 7, okay, over, and then the bottom, let's just keep everything as is. So I'm not going to touch the bottom yet, okay? On the top, or actually let's try plugging in x is 2 now. What do we get on the top? We would get 4 plus 5, which is 9, minus, this is again 2 plus 7, which is 9, okay? The bottom, we would get 0 times 0. Okay, so we got to do something. Okay, so we still get 0 over 0. So let's simplify. The top, we would get what? Limit as x goes to 2. The top, we would be left with 2x minus x, that's just x. 5 minus 7 is x minus 2. So, oh, look. Conveniently, we'll be able to cancel something. Okay? So this top x plus 2 can cancel with that one. Now we can evaluate the limit by plugging in x is 2. The bottom, we would get what? 1 over, that would be square root 9 plus square root 9, okay, which is 1 over 2 root 9. Do we have that as an answer? Well, actually, we can simplify, because root 9 is 3, which is a sixth, okay? A sixth, that is B. Okay, let's circle that. Next, integral from 0 to 8 dx over 1 plus x. Okay, this we can do a little substitution if we let u, let me do it here, u is 1 plus x, du would be dx. So we can rewrite the integral as, we need to change the limits of integration. When x is 0, we just plug it in here. U is 1 plus 0, which is 1. When x is 8, u is 9. So we get what? Du over square root u, which is, this is u to the negative half, so it'll be u to the half divided by half, which is 2 square root u, evaluate from 1 to 9, which is 2 times square root 9 minus square root 1, which is 2 times 3 minus 1, which is 2 times 2, which is 4. Answer is D. Okay. We have this next. 3x squared plus 2xy plus y squared is equal to 2. The value of dy dx at x is equal to 1 is what? Okay. So we need to implicitly differentiate this. So let me do it over here. I don't know if I have enough space there. So 3x squared plus 2xy plus y squared is equal to 2. Okay? When we implicitly differentiate, we get what? Derivative of 3x squared is 6x. Here we need product rule. It'll be first d second plus second d first. First d second derivative of y is just dy dx plus second d first derivative of 2x, just 2. Then we need a derivative of y squared, which is just 2y dy dx. Derivative of 2 is just 0. So we solve for dy dx. What would that be? This is 6x, this is 2y, so minus 6x minus 2y would be on this side, and then we start these two terms here. So if we factor out the dy dx, then we would get 2x plus 2y. Okay, so it'll be like this, okay? We need to evaluate at x is 1. Well, we need a y coordinate too, because this is in terms of y also, so how do we do that? Well, maybe if we plug in x as 1 to here, we can get a value of y. So 1, x equals 1. We plug it into our original function. It'll be 3 plus 2y plus y squared is equal to 2. Okay, so we would get what? Y plus 3 plus actually, you have to move this to this side first. It'll be 1 plus 2y plus y squared is equal to 0. So this is just y plus 1 squared is equal to 0. So y is negative 1. So when x is 1, y is negative 1. So we plug in 1, negative 1 into our dy dx. We would get what? Negative 6 plus 2 over 2 minus 2. Oh, divide by 0. This is infinite. Or it does not define. Okay, that's the answer. By the way, I do have the key for this, so I'm checking all my work. Again, all my final answers against the key. And they've been correct so far. Okay, let's move on. What is this limit? Okay, so obviously we try to plug in h is 0 first. We would get 8 times half to the 8th power minus 8 times half to the 8th power, which is the top would be 0, bottom would be 0, 0 is 0, indeterminate. Okay, so we have to do something else. Okay, or do you recognize that this looks like the derivative, the limit definition of the derivative? Okay, hopefully you do recognize that. Okay, after we tried just plugging it in, okay, that clearly didn't work. Or it's indeterminate, so we gotta try something else. But we recognize that this looks like derivative. And it's actually asking us about, I can even write it here, f prime of half. Okay? So what is f in this case? Remember, limit definition is, let me just write it over here, limit as h goes to 0, f of x plus h minus f of x over h, okay? This is f prime x. So f prime of half, we just plug in x as half. So see the half plus h and the 8 times. So hopefully this looks right. So f would be 8x to the 8th power. Hopefully you see that, okay? So f prime would be what? 64x to the 7th. We evaluate this at x is equal to half. Okay, so what is that? What is half to the 7th power? Now that's a challenge. What's 2 to the 7th power? Well, 2 to the 4th is 16, to the 5th is 32, to the 6th is 64, to the 7th would be 64 times 2. So it would be, f prime would be half. Okay, so f prime at x's half would be half. So let me just write it like this, equals to half. So it's actually b. Okay, so one more time. We recognize that this is the derivative. Okay, this is the limit definition of a derivative. Okay, so our f looks like it is ax to the 8th power. Okay, and we're valuing the derivative at x's half actually. So this is actually f prime of half, as we said over here. So first we find f prime, which is just a power, 64x to the 7th. We evaluate the derivative at x's half because that's what we want. The end result is half again. So that's the answer for that. Next, for what value of k will k over x have a relative max at x is negative 2? Okay, so I'm thinking right now, because it's talking about relative max, you probably want to find the derivative of this guy and set it equal to 0 or something like that. Okay, so let's try that. I don't remember how to solve this actually. So we'll see if I had the right thought process, okay? So once again, I'm thinking it's asking about relative max min, or max in this case, so maybe let's take a derivative, okay? We have x plus k to the x. Let's call this f of x, okay? F prime of x would be 1 minus k over x squared, okay? Let's set this equal to 0, okay? Because we know that when there's a relative max at x is negative 2, the derivative at x is negative 2 is 0. So we want this to be true at x is, what was the value? Negative 2. So let's plug in negative 2 here. It'll be 1 minus k over negative 2 squared, which is 4, is equal to 0. Okay? So let's solve for k. So 1 is equal to k over 4, or k would be equal to 4. Is that the answer? 7D, yes. Okay, so the key here was it talks about relative max, so the hint was take derivative of this guy. Okay, excuse me. If p of x is x plus 2, x plus k, and if the remainder is 12 when p of x is divided by x minus 1, then k is equal to what? Okay, this one is more like an algebra type problem. In my opinion, I don't think they'll ask this in AP Calc AB. But, you know, I don't know what the current state of the course is or, who the test writers are. But anyway, so basically this is saying, okay, so let's rewrite it here. P of x is what? X plus 2, x plus k. Okay? Remainder is 12 when p of x is divided by x minus 1. Okay? So p of x divided by x minus 1. Okay? This is some quotient. So let's call it q of x. And the remainder is 12. Okay? I believe it will be something like this. Okay, I don't know if the video just jumped. I was checking what the key said, and I think I'm on the right track. Okay, so what was the question asking? What's the value of k? Okay, so how would we find k here? Okay, let's plug in p of x is this guy. Okay, so x plus 2 x plus k over x minus 1 is some quotient plus 12 over x minus 1. Let's multiply both sides by x minus 1. So x plus 2, x plus k is q of x times x minus 1 plus 12. Okay? So this has to be true for all values of x. So let's plug in some value like x is 1 to get rid of this term. So we get 1 plus 2, 1 plus k is equal to q of x times 1 minus 1 plus 12. Okay, this would go away. We get 3 times 1 plus k is equal to 12. 1 plus k, we divide both sides by 3 is 4. K is equal to 3 is what I get. And that's the answer, according to the key. So k is 3. B. Okay, hopefully that made sense. When the area in square units of an expanding circle is increasing twice as fast as its radius in linear units, the radius is what? Okay, so I like to just write down, jot down everything they give us, okay, including formulas. So when the area of an expanding circle is increasing, so let's say its dA dt is twice as fast as its radius. So this is saying 2 dr dt. Okay, twice as fast as its radius in linear units. The radius is what? Okay, so this is the derivative relationship. Do we need the area of the, what's this, circle? So area is pi r squared. So if we differentiate this, it'll be dA dt is 2 pi r dr dt. Okay. So if we plug in 2 dr dt as dA dt, what happens? 2 dr dt is 2 pi r dr dt. This would cancel with this. This 2 would cancel with this. So 1 is equal to pi times r. R is 1 over pi. I believe 9 is C. Yes. Okay. So not too bad. So once again, it said that area of an expanding circle is increasing twice as fast as its radius in linear units. So that's this relationship here. dA dt is 2 times dr dt, okay? We know what the area of the circle is. Area is pi r squared. So we differentiate this guy with respect to time. We get dA dt is 2 pi r dr dt. We plug in dA dt as 2 dr dt. That's what we did here. We start canceling things, and then we only have r left. We solve for r. Okay? The set of all points e to the t, comma t, where t is a real number, is the graph of y is equal to what? Okay, so this should signal as, well, if y is equal to t, then x is just e to the y, right? So you can write it as x is e to the y, and then we just solve for the function y, the variable y. So y is just what? Log x. 10 to z, as simple as that. Okay? So here I recognize that, well, the y coordinate is t. So since y is equal to t, this is the same, x is the same thing as e to the y. Okay? X is e to the y, we just solve for y. Okay? The points on the curve x squared plus 2y is equal to 0, that is nearest to the point 0, negative half, occurs where y is equal to what? This sounds like an optimization problem, okay? So what are we optimizing? We're optimizing the distance between the curve, some point on the curve here, and this point. Okay, so we probably need the distance formula, okay? So if we say the distance is L, I don't want to say D because we're going to differentiate in a bit, is x squared plus y squared, right? Something like that. I'm not sure if that's a good notation, but this should sound familiar, right? L squared, sorry, is x squared plus y squared. Distance squared is x squared plus y squared, okay? So let's redo it. The distance would be some x1 minus x2 squared plus y1 minus y2 squared, something like that, right? That's the distance formula. We know the relationship between x and y for one of the points, and we know one of the points here. Okay? So we can, okay, so plus 2y is equal to 0, and the point what? 0, comma, minus half. So let's plug things in here. L squared, sorry, L is equal to this. Let me just square it so that we get rid of square root. So it'll be what? If we leave x alone, can we do that? Or should we leave? Yeah, let's leave x alone because we can rewrite this as 2y is equal to negative x squared, or y is equal to negative x squared divided by 2, okay? So we can say this is x minus the x coordinate here is 0. Okay. I don't know why I'm still squaring. Okay, sorry. Distance is something like this, okay? So no question about the distance formula. Let's square it so that we get rid of that square root. Let me write things clearly. Okay, so L squared is equal to, let's leave the x alone. The x coordinate for this point is 0, okay? Y, we can express it as x, so negative x squared divided by 2. Okay, minus the y coordinate would be negative half, so plus half squared. Okay? So we can differentiate, so it'll be 2L times dl dx would be equal to, here is just x squared, so that's just 2x, plus, here we could either expand it out first, or we could just use the chain rule. If we use the chain rule, it'll be 2 times negative x squared divided by 2 plus half to the first power times derivative inside, which is negative x. The derivative of this first term would be negative 2x squared divided by 2, negative 2x divided by 2, which is just negative x. And derivative of the next term is 0. Okay, so this is that. So then dl dx, okay, let me just write the 2l there still, okay, is equal to, let's try to clean this up on this side. That would be what? 2x minus 2x minus x squared over 2 plus half. Okay, so 2l dl dx is 2x plus, that'll be x cubed if we distribute. Is that correct? That seems correct. And then this would be minus x. Okay, dl dx, let's divide by 2l, would be x cubed. I'm going to rearrange that term, and then this will be plus x divided by 2l. We want to set it equal to 0 to optimize. Okay, so multiply both sides by 2l, we are left with x cubed plus x is equal to 0. Factor would be x squared plus 1, 0. So our solutions are x is 0, and what is that? X is 0, and that, there's no solution, no real solution for that. Okay, so x is 0 would be the x coordinate of the point on the curve. Okay, since if x is 0, then we just plug it in here. So y is 0 over 2, which is 0. Okay, so the point 0, 0 is actually, so when y is 0, it's actually the nearest point. Okay, so that's the answer, which is correct. But let me recap one more time. I was a little disorganized in doing this. Okay, so we're talking about the point nearest to this curve, nearest to this point on this curve. Okay, so we want to minimize the distance. Okay, so we want to optimize. So this is the optimization problem. Okay, we need two equations: primary equation, secondary equation. Primary equation is the one we're optimizing, so we're optimizing distance. So I just called it L is equal to square. This should look like the distance formula: the difference in the x squared plus difference in the y squared. Okay, I just named it as x minus x0 squared plus y minus y0 squared under the square root. Okay. We have one of the points that's 0 and negative half. We know the relationship between x and y of the second point. Okay, so we can just leave that generic. Okay, and actually we can rewrite this as y in terms of x. So I solved for y first. Y is negative x squared divided by 2. Okay. So I just plugged into the distance formula. Well, first I squared it to get rid of that square root. It'll be x minus 0, that's this point squared, plus y, but y is defined by negative x squared divided by 2, and then minus negative half, so it becomes plus half squared. So this is the distance formula. And then we differentiate it to optimize it, right? So 2l dl dx equals to, this is just x squared, that's 2x, and then this is chain rule over here. We did some cleaning up of things, and then we set it equal to 0. That's how we optimize. So it's an easy thing to solve. We multiply both sides by 2l. We have left with x cubed plus x is 0. We factor. The only real solution is x is 0. When x is 0, then y is also 0 because we just plug into this curve. So when y is 0, that's the nearest point. Or when it's at the origin, actually, it's at the nearest point. The y coordinate of the origin is 0. Okay. We're nearing the 30-minute mark, so let me see how easy these problems are in the upcoming sheets. Okay, let me do a few more. If f of x is 4 over x minus 1, g of x is 2x, then the solution set of f of g of x and g of f of x is what? Okay, so let's first find f of g of x. So wherever there's x, for f, we plug in g of x. So f of g of x would be 4 over 2x minus 1. Okay? And then g of f of x, wherever there's an x in g, we plug in f. Okay, so it'll be 2 times 4 over x minus 1, which is 8 over x minus 1. Okay, so I'm doing this problem over here. Okay? So the solution set is what? So we set these equal to each other. So 4 over 2x minus 1 is equal to 8 over x minus 1. How do we solve this? We can just cross multiply, right? There's probably multiple ways to do it, but let's just do it my way first in this video. Well, this is me doing it in this video. 16x minus 8 is equal to 4x minus 4. That's 12x is equal to 4. X is a third. Okay? Is 12a? Yes. Okay? So this is, you need to know composite functions. As simple as that. Region bounded by the x-axis and part of the graph y is cosine x between x is negative pi over 2 and x is pi over 2 is separated into two regions by the line x is equal to k. If the area of the region for negative pi over 2 less than equal to x less than equal to k is 3 times the area of the region for k less than equal to x less than equal to pi over 2, then k is equal to what? Okay. So this is talking about area, so maybe let's sketch this region real quick. It's not that hard. Cosine x, we should know it looks something like this. It will oscillate, but this is between negative pi over 2 and pi over 2. Okay? So this whole thing would be the region. Okay? We separate this region into two regions by the line x is equal to k. So there's some x is equal to k. Okay? And it's saying that the area from negative pi over 2 to k is 3 times the area of k to pi over 2. So let's write it in integral form. Area of the curve under the curve is, the integral is area under the curve. That's what I'm trying to say. So integral from negative pi over 2 to k of cosine x dx. Okay? This is 3 times the area from k to pi over 2 cosine x dx. Okay? So we got to solve for k. Okay? So this is just sine x, evaluate from negative pi over 2 to k. That's the left-hand side. The right-hand side is 3 sine x, evaluate from k to pi over 2. So the left-hand side would be sine of k minus 1, because sine of negative pi over 2 is negative 1. Okay? The right-hand side would be 3 times 1 minus sine of k. Okay? So let's solve for k. Sine of k minus 1 is equal to 3 minus 3 sine of k. This is not sync, it's sine of k. If we move the sine k to this side, it'll be 4 sine of k. And then is equal to 4. We move this one to that side. So sine of k is equal to 1. Where is that equal to? At least it has to be in this region, right? In this interval. So k is equal to... Actually, did I do this right? Yes, sorry. This is, where did what number is this? This is 13. I think I made some math here, actually. Let me double check. Is it because this is minus negative 1? Is that the reason why? Okay, so if that's the case, then this is just 2. So sine k is equal to half, or k is equal to, what is this? This is pi over 6. This makes more sense, because if it's at, if sine k was equal to 1, that's at pi over 2, which doesn't make sense at all. So I knew I had made some error, okay? Sorry about that. So this was, the setup was still correct. I just made some math problem in doing the fundamental theorem of calculus. So k is pi over 6. 13C, yes. Okay, first mistake I made. All right, 2 more problems and then I'll call it a part. If the function f is defined by f of x is x to the fifth minus 1, then f inverse is defined by what? Okay, this is not hard at all. to find the inverse, we switch the y and the x, if you remember. So if this is y is x to the fifth minus 1, we say x is equal to y to the fifth minus 1. And then we solve for y. So it'll be y to the fifth is equal to x plus 1. So y is equal to x plus 1 to the 1/5 power, or to the fifth root. Okay, so that is E. And the last one, this is probably a more conceptual one. F prime and G prime exist. F prime is greater than G prime for all real x. And then the graph of y is f of x and the graph of y is g of x. Okay, let's go choice by choice. Does it intersect exactly once? Well, okay, so if f prime is greater than g prime, we know that f prime is increasing faster than g prime. Or if g prime is even decreasing, because if g is decreasing, all right, back up. F is increasing greater than g is increasing as a faster rate than g is, but by this derivative over here, okay? Because f prime is telling us how fast f is changing, right? G prime is telling us how fast g is changing. Then since f prime is greater than g prime, f is increasing faster than g, okay? And in fact, it could possibly be that f is increasing, g is decreasing. That's possibly the case. But more generally, f is increasing faster than g, okay? So, do they intersect exactly once? Well, if f started bigger than g, then they're not going to touch at all, because f is increasing even faster than g. So it's probably not that. Okay? Intersect no more than once. Okay? This is more likely, as I just said, if f starts bigger than g, then they'll never touch. Okay? If f starts less than g, since f is increasing faster than g, then they're going to touch once. Okay? But no more than once. Do not intersect is not always true. As I just said, if f starts less than g, and since f is increasing faster, it has to overtake g. Okay? Could intersect more than once. That's not true. I just went over that. Have a common tangent at each point of intersection. Common tangent at each. That's not true, because f prime is always greater than g prime. The tangent would not be the same. Okay, so that's false. So we're left with choice B. Okay, hopefully that made sense. Okay, so we'll call it a part here. So please give this video a like if it was helpful. Please subscribe to the channel to get notified for the second part of this.